section of our training here today. So building, there's a lot going on. Hopefully the things that we
Sorry,
talked about.
Adam, your voice is kind of low.
I did not have the microphone in front of my mouth. I'm sorry. Uh, Thanks for pointing that out, Helen. Um, Thank you everybody for sticking around for the last and final section here. The first part of this, we're going to actually talk about some additional building tips. So I think that building containers, there's a lot going on. And so hopefully the kind of the introduction that you just had, we didn't throw too much information at you. We're going to throw a little bit more at you now, but hopefully this doesn't confuse you and you don't miss out on or lose any of the things you've already learned. So first, I want to talk very briefly about multi-architecture containers. So Perlmutter itself is a Linux AMD 64 machine, right? So it's not an ARM CPU, it's a AMD 64 machine. And so this is when you build on Perlmutter, it's going to build for the architecture like Perlmutter by default. And that's going to be true wherever you are building. So the reason this gets people into trouble is that if you're building, say, on your newer Mac, using Docker or Podman there, and then try to push to Perlmutter, it's going to be the wrong architecture. So you'll often do either a multi-architecture build so that it will run either place, or build for the architecture for the machine that you actually care about. So I want to just bring this up because it's something that you'll have to do. But this is something that is nice about building on Perlmutter, is that this is already set up and ready for you. But if you are going to be building elsewhere and then pushing to a place that you can pull onto Perlmutter, this is likely going to be something that you'll need to take into account. And as I mentioned, you can do multi-architecture builds. So if you're building for the architecture that your computer actually is, it's going to be much, much faster than if you're building for a different architecture because it's trying to emulate things. And there's just a lot of overhead associated with that. Also, if you do a multi-architecture build, that container is going to be considerably larger than the single architecture build. So my recommendation is if you're running on Perlmutter, build it on Perlmutter, right? It's just going to be a lot easier overall. However, if your workflow requires you to do other things, you have the ability to do these other things. This is something that that you can do to be able to push onto any other place that you're doing compute. Now, we've also talked a little bit before about the tags and the version numbers, right? So that version, so here in this particular example, this 1.2, as you're building things, you can continue to iterate and build this up. There are a lot of people that use latest as a tag, and you can, that works well if you really, if you're just looking for something simple. The problem is that you're trusting the person to keep that up to date, right? Whoever you're relying on. And then the other thing is that it makes it harder for you to come back later and say, oh, what version was this? If I want to reproduce something, right? And part of the reason that we use containers is in our pushing containers is because of the reproducibility. And so it's good to use the exact version. Or, for example, if you're similarly, if you're getting something from, cloning something from Git, to use a one of the hashes as opposed to just grabbing what's on the top of main, just so that you have the exact information of what is there. And I do want to point out, and I think that we had a question in the Q&A document that hinted at some issues here. I'm not exactly sure where the mistake was, but occasionally if you build something with the exact same container name and tag, there's some sort of mismatch, and Podman HPC just kind of raises hands and says, I don't know what I'm doing. So if you do come across things like this, the easiest things to do are shown here in green, right? So you can try to make sure that the versioning issues are taken care of by just getting rid of an individual tag. But because all of your blobs are still going to be there, if you try to rebuild, it's going to be very, very fast. The things that are shown in kind of the yellowy orange color, these might take you a little bit longer to rebuild the containers that you had. And then the things that are shown in red, don't do these unless you absolutely can't get anything to work. And this will basically get rid of all of the things that you have cached. And so you'll have to rebuild everything from scratch. But when you do that, there won't be any contention between the containers that you're working to build and the containers that you already had. And so you'll know that you won't have to deal with any issues anymore. We do have in our docs more or less these exact same things with a little bit more of a description of what some of them are individually. Although the color coding and here are the things you should try first in green, that's not as clear in the document right now. All right, so let's talk a little bit about other ways to use containers here at NERSC. And so the one that I really want to bring up to people's bring up really first and foremost is spin. So most people, when they talk about containers, they're not talking about HPC containers. Right? So for everything that we've done, we started the container, started the job, did something, and then brought the container back down. Now, most people, when they talk about containers, are talking about things that are running persistently. And if one container isn't enough, they'll spin up another. Or if something is failing, they'll just swap it out for a new one. And we do have a host for persistent containers to be run on, and that's called Spin. This is something, if you have a database that people need access to, we have a couple of workflow managers that are looking to see if new data is available that will then start other jobs, or if you have scientific gateways. These are all things that people at NERSC have been using our Spin service for. So not, the containers will look a little bit different than what we were working on today, but the way that you build them is very much the same. And then you just have to put them in a location that the Spin service can actually use. So our Spin, we have a wonderful team that supports the Spin service, and they have a great website. They do trainings roughly quarterly, give or take. And so it's a very easy way to get a scientific gateway up and going if that's something that you're interested in. Their documentation is pretty good, and they can tell you about all the different things that you can and can't do on Spin services. But I did want to mention here, as we're talking about general HPC containers, that HPC containers aren't the only way that containers can be used, and not the only way even at NERSC. So Spin is another thing that I would recommend people look into if they have a need for it. Everything that we've done today is on the command line. That's where I have lived my entire computational career. That being said, we have many people at NERSC that are using Jupyter and want an interactive way of doing compute. And so Jupyter is a fantastic resource. One of the things that is super neat about it is that we can actually make a custom Jupyter kernel for you, or you can make it for yourself. And so I've given some instructions here about how to do that. So really, the interesting thing here is that you get to have everything customized for your environment, and then bring it up within the NERSC Jupyter Hub. And so you can have the latest and greatest software. You can use something that is tried and true. You can use something for the entire duration of your set of computational runs for a paper. You have control over that environment. And so the docs document kind of goes through this from a high level and really discusses each of the individual steps. But if you are interested in doing this, I put down more or less the standard things that you need to do. Right, so you're going to build your container and just throw that IPy kernel right in there, and then you have to set up a kernel spec doc, and really that's something you'll put in your home directory. And then once you set all that up, you're going to start up Jupyter just like you usually would, and you can select your environment. Right, Jupyter will know where to look if you set things up in the right way. It'll look in these specific locations and then have that kernel available for you. So this is really an interesting way to kind of customize your environment, even if you want to use something like Jupyter as opposed to the command line things that we've been working on for today. And then so here at NERSC, we use containers for a lot of things, and this is a list that has been growing. we have just some great documentation for how to do a lot of different things. I did see a question right before I jump back over about MPI and how to use that. We don't have specific training about that, but we do have some documentation for it. In addition to that, we have some documentation about how to run multiple containers within the same job at the same time in Shifter. You can do some graphics forwarding with Podman HPC. This is something that a lot of people that are doing some different debugging will often use because of some of the debugging tools. We do have the Cray PE that's available for or on Perlmutter. We have some instructions for how to pull that into a Shifter container fairly easily, just so that you have the latest and greatest from our program environment. They're available to you. I mentioned before with the graphics forwarding, but then if you'd like to do some other sorts of profiling, profiling in containers does look a little bit different just because of the way that this is set up. But it's possible, it's feasible. We have instructions for how to do it. We have a lot of people now that are using VS Code, which is kind of an interesting thing to do in and of itself, but let alone in a container. We have a lot of people that are doing SPAC and then PyTorch as well. I think SPAC, I pointed to a couple of people that had questions to some different things in the Q&A document. But then a lot of our applications we're also putting out for people in containers. And I think that this will expand greatly in the next, the coming months, we'll say. We're actively working on this. We're trying to make sure that we have containers to support the bulk of the people on our system as far as the biggest applications for compute hours, both so that we have that for them as well as so that we know how to make sure that we're getting good performance on our system. And this containerization is a good way for us to do that. So with that, we have kind of one more slide here. Where do you want to go from here? And that is completely up to you. This is, as I mentioned before, this is kind of a generic training, a very generalized training to get you up and going with containers. Our documentation is very good, and we have some good examples in there of how to do some different things. As you probably saw in the previous couple of slides, we have some specific things that are in containers that are documented elsewhere. And so if you're interested in those sorts of things, feel free to peruse our documentation overall. You might see containers far more often than just in the container sections. And then really the next big thing is to get started using a registry, right? Figure out where you're going to be storing your things, whether that's on our NERSC registry on Harbor, on Docker Hub, on Quay. These are all great resources. I use them all myself. And it's just more up to you with, what's going to work best for you. So we do have help tickets. Those get routed around to different people that know what they're doing with containers. We also have NERSC user appointments. So if you have some specific questions that are, not just the general stuff that we've talked about today, but with your application or with your container, we can set those up. And so I'd encourage people to take advantage of those resources that NERSC offers. And with that, I'm going to ask you one more time to fill in the survey, both to help us fill out our trainings as well as make sure that the trainings that we're giving are as good as possible. And I think that's about it. So let's see, we have the Q&A document. We're going to stick around and keep working on that for, say the next 15 or 20 minutes, make sure that we get the questions answered. But yeah, thank you all for coming. And again, please fill out that survey and yeah, happy computing.